In this demo, we're going to set up cluster using our automaton script. So we have a checkout of the Go code. So we're going to invoke the application. Provision. So right now the code program go and check to the nectar and it grabs all the current provision. And then since we already have a 4 provision, so we can see that. So but now we don't really need to, if you like to create new instance, we can say yes, otherwise we can choose no. So since we already have instances, so we will say no. If we say yes, then we can go through the provision of new VM instances. So this next script, we can pick the available resources. Again, this will be the 4 instances we previously created. So over here, we can choose by giving a number, like say 1, 3. So that in that case, we are choosing 0 and 3. But we can also use all instances to do what we like to configure, install for the system. So in this case, let's say we choose A. So then we say that we selected all the instances. So now pre-flight check, this is to say that what we like to do with this provision. For example, we do CouchDB cluster provision. In this case, I would just use the default CouchDB. Otherwise, we can define something different here, and I will choose the default one. And then we can give a file name, the host name. This will be written down all this IP address into this file, and we can leave it as a default hostname.ini. And then now we can go through the firewall setting and then go through, say, whether we wanted to open some firewall. So we will open some firewall. For example, we go through, say, yes. Then this will show that our current security group, and we have a default security group and SSH. So we choose 0, our default security group, to open some ports. And so that port number we like to open, say for example, we like to open port number 8090. Then it will try to check the current and then try to insert that opening port. So it's already inserted. And then we can actually open multiple ports by just separating, keep adding more ports. And then now we can also go through the volume provision if we have some volume to attach, create, and things like that. So maybe we create, say for example, we provision a volume, say yes. Then it was asked, do you like to create new volumes? Then I will say yes. And then how many volume? Maybe I will say 1 volume. And then maybe under the side, so I say 1 gig. So we're trying to create 1 gig, for example. So the volume is created. And then it says that its volume is created in this zone and available now. So now we can select this volume to attach it to the instances right away. So it's asking, do you like to attach volume? Then this is the same things that we've done with the you can see all the previous volume here. We have a 62 gig 4 in 62 gig volumes, which is already attached to the our instances. So because since we already attach it, so we will say no to now, and then, or maybe we will say yes, and then pick an index number, which is from the available resource from the indexes. Say I will attach it to instance number 0, and then we have to provide the block address. So we will say device and VDC. So we will go VDD. So this is done. Now volume is already attached, and then now we are reaching to the Ansible part where we start our automation, main automation of installing the CouchDB. So it's checking all the hosts, scanning all the SSH, make sure all SSH are able to attach it, because Ansible requires SSH to attach to communicate. So now we have all done. So now we can choose our login username. By default is the Ubuntu, so we choose Ubuntu, and then now we can, oh okay, I click it a little bit. So there's a one step is asking where our playbooks. So say for example, this is a playbook where we store, and then we select that playbook part. We can, if it is different, we can select it, but this is the default. And then now we can define our the playbook recipe, which is a this is by default is a test YAML. We can select, say for example, couchdb.ym and then enter. But since we don't want to do this right now, because that's already been set up with all the 4 instances. So what we do, we will just simply go with the our test YAML. Basically, test YAML will just echo all the hosts, and then it will come back. So for here, we can even choose, say for example, all sort of whatever playbook script we've been written in the automaton playbooks recipe. So we have a CouchDB cluster set up automatically in this way. We have Spark cluster set up in this way, and then we have set up our application automatically set up in this way. So I will just use the test and go on. And then at this point, we can say whether we like to verbose the whole operation, and then we can say yes for now, then so that we can see all the verbose output of the Ansible. So now at this point, it print the whole thing. It says that this is what we want. Do you agree with this comment? I would say yes. So I would say yes. If you say no, then the script will be abort. So it will become like more dry run rather than so you can do that. So if I enter, just simply enter, then it will take as a dry run, and it will abort the script. Otherwise, you can say yes, and it will really executing the host. So we will say yes and go. So now the script will launch in T- time. Okay, taking flight. Have a rest. Take coffee. So now you can see, because this is just a YAML script, it's just echo, so it's simply echoing all the nodes, and it come back and says that I echoed all this thing. So this complete the demo of the automaton. Thank you. Now I'm going to present this slide. Basically how we achieve the cluster setup on the Nectar. So with the team resources, we have 4 instances. So with 4 instances, we provision to run a production database, which is using CouchDB cluster setup. So we have a block device, 2 block device. One is VDB and one is VDC from each VMs. VDB is about 50-60 gigs, and then VDC is also similar in the size. And then VDC is from the volume store. So we attach it during the automaton script setup. Then our CouchDB is deployed under the VDB. And then the key is here is to so that we can do a backup of the each node. So from the VDB to VDC, so we have a backup script running through VDB to VDC backup. So we have a better backup with this way. That's a one thing concerned with the database. And the second thing is we configure our database such that we have a HStrat and then 3 replication factor. So with this, we can have it up to 24 nodes. That means 8 times 3. So that means we can have it, each node has a one strat. So we can scale up to there. In that case, say for example, in each database, now because of 4, we only have we will have 6 strats each on each database. But later, if we put another machine, then we can shuffle this strat into that new node, so that we can have a better capacity without shutting down the system. So that's the good things about the CouchDB cluster. And then secondly, I mean, we have this HA proxy in front of the production DB, and it simply use a round robin schedule. That means our application connect to HA proxy, then proxy will do the load balancing, and then basically using round robin and go around this cluster. Then we have it. We have the Spark cluster here. This should be ideally this should be another separate cluster using totally different VMs to do the Spark application, but somehow we are limited to only 4 nodes here, 4 VMs here. So what we do is we just reuse this 4 VM as a Spark cluster. In that case, we just be careful with the when we really do go with a full load on a Spark cluster, we are trying to reduce the workload on the CouchDB related, but CouchDB pretty much load is pretty much small, so it's pretty okay that we can use it both in our experiment. We can use it both in parallel anyway. I mean simultaneously. I mean when running some Spark application, we can also keep it running the production table, inserting Harvester to insert the data, and we don't really need to halt the application. So then for the Spark, because we need a one master node, so what we achieve is we achieve 6 core and 21 gigs in total resources. That is, each VM has about 8 gig, but we only have 7 gig, so 7 gig times 3, that's about 21 gig. And then each VM has a 2 core, so total is a 6 core. So we have a 6 core, 21 gig Spark application running, a cluster running here, which is the another row of the consider say production DB. And then what do we have? We have make use of our private Nectar instances. Each of our private Nectar instances to set up test environment down here. So we have a total test DB. We call it test DB, which make use of 2 VM instances of the cloud cluster, so that we can write our program and develop our program and test against this test DB, independent of not interrupting the production operation of the proc DB. And then the same scope here, we have a Spark test cluster here, which is making use of 2 nodes. This one, this 2 nodes is even more busier because we run our web application on here, test code here, run our anything goes here. And so this two nodes is called Yin and Yang. So the node name is Yin and Yang. This doesn't have any names. Yeah, that's so. So basically, we have a 1, 2, 3, 4 cluster in mind with HA proxy running there, and then the whole cluster are automated and making use of our automation script and set up all this in the within a couple of seconds, and then we can do so again and again if we like. So and then this whole thing is house our application, Harvester, Analytic, and web application. And then all the technology driven behind are making use of OpenDo, Linux, Python, Ansible, and Bodo. Thank you.
Okay, so here I will give a little bit introduction about the whole process of our system. As you can see from the left, there are a bunch of tweeters coming in and harvested by the harvester that we use basically 2 APIs, which is the first one is streaming and the second one is search. So for the streaming API, we are basically harvest all kinds of tweets in Australia, and it will be used in the later process. And for the search API, and we decide to that depends on what topic that we want to go through. So this little kangaroo wanna analyze the people in Australia think about Trump, which is just the topic that we want to go through. So in analytics, I will go more details about the Trump case. So in here in the harvester, we defined in search API and the keywords to be Trump. So all kinds of all tweets that we get from here, it's about Trump. Before saving that into CouchDB, that we decide to tag them by the sentiment analysis library built in NLTK, and we use that little program to tag each tweet. Say this tweet is positive against Trump, then we just tag that to be pause, and if it's negative, then we tag that to be neg, and we save that result in CouchDB. And here it's the process splits into 2 parts. This one is analytics, and the second one is visualization, which is for the website. So in analytics, we have basically two functionalities. The first one is about Trump that I just talked about. You may wonder why we want to retag a program in here. So as I mentioned before, that we use streaming API to get all kinds of tweets in Australia, which is not being tagged. Only the search API tweets, harvested tweets is tagged. So in here we need a retagger program to run through the tweets by streaming API to tag them to be either negative or positive. And we want to do that on Spark. The reason why is that we start this streaming API harvester very early, and we got a bunch of very large data size tweets, and we need a very powerful and efficient framework to help us to do that. So that's why we run on Spark, which gives a little bit of surprise to us that it does run very fast. And the second one, and after that we save that into CouchDB, which the result will be used for the website. And next one, the second functionality is our main functionality, and it's what we're dreaming about, and we want to develop more in the future. So this functionality is about subject detection, and we decide our first very basic functionality to be the crime detection. So we want to know what kinds of the people in Australia, in which area, is talking about crime, which can lead to analysis about their safety issue in further process. So in here, we do crime detection, right? And we the ideas for that is to compare the words in a sentence against a specific topic about crime, and to calculate that similarity between the words in the sentence and the topic by Wool-Palmer algorithm. And we will calculate the score for each sentence, and save that in the CouchDB, which is the result after this little program. And this process is also run on Spark, which you can guess why, because we are basically using the streaming APIs tweets, and mentioned before, that's very big. And after that, before the website, you fetch data from CouchDB, and this resource in saved in CouchDB is still not the format that we want for the website visualization. So we use MapReduce in CouchDB to process further of those results. And what we do is that, say for the sentiment analysis, so we want to know that in which cities and people is more showed more supportive for Trump, and we just do the MapReduce on and get the result like in Melbourne, and there are about 200 people support Trump, which shows that the tweets it's positive, and about 100 people support says bad words to Trump, which to be negative. I will just show that visualization and do a bit analysis and show on our website. And for the crime case, that we do a bit different here. So as we have result from a crime scenario, and we need that to be processed by MapReduce to get the score, which is greater than the baseline. So in here, the baseline concept is that we run a program to decide the baseline, which is the basic score that we want to decide whether this tweet is about crime. So say for example that we have the baseline to be 0.2, and we have the score for that tweet to be 0.3, and as 0.3 is greater than 0.2, which means that this tweet is about crime. So we run that program against the whole streaming data, and we get the idea about the baseline, and we save that in QuadDB and compare that little value with each value in QuadDB and do MapReduce to get the tweets that we want. And then we do another MapReduce on that result to get which city people talks about crime, and we count that number for each city and show the result in our website. So for the next procedure, that after this, I will introduce you our website, which gives you a little bit more about what we want to do, and I will show you in the website. Okay, here comes our very last part, which is the website. It's a very beautiful website, maybe because of the beautiful background image. So our team name is Go, as you may know, and there are some small details I want to show you. So for the first part is this little scroll bar that gets streaming Twitter from QuadDB and harvested by the streaming API. And as you can see, if I scroll down, it goes to this, it goes to the top, and you can check that in every sections. So here comes the fancy navigation system. So you can see this effect is good. So okay, so for the first part, home, system design, that talked in last section, using technologies, chart. Okay, this chart, we use HighChat to give a very good effect. You can see here. I will go through that later. Okay, and here's the analysis part. And the heat map is against the crime detection part. We'll talk about that after. Okay, team member, pictures, photo. Okay, so I'll start by using technologies. Okay, so for the website, for the cluster deployment, I think we may use QuadDB, Nocta, and maybe Ansible. Yeah, those technologies that we use. And we use 2B for the API. We use 2B API to harvest Twitter. And Node.js, React, Django Webpack, and then NPM is mainly for the website development, and LTK is for the sentiment analysis, and we use other libraries also for the crime detection. And we have Spark deployed in every cluster, and it's powerful for our functions. Okay, here comes the analysis part. So yeah, and if you hover page bar, you can see the figures of that. So this chart is about sentiment analysis of people's positive and negative attitude rate for Trump versus bachelor rate of each Australian major city. So what it tells is that the people in Australia major cities, the people who get bachelor degree, we want to know that if they support Trump or not. Okay, so we got a little bit idea from this top part. We found in Melbourne and Sydney the number of people who has bachelor degrees quite small, and people with a bachelor degree tend to support Trump from these two graphs. And on the contrary, by observing the bar chart in Brisbane and Canberra, more people gain their bachelor degrees in these cities. As you can see, the bar is very high. And they are not supporting Trump as Melbourne and Sydney does. This means Trump is advocated by those people with nice education. This is actually the same as the media reported. Trump's policy is beneficial for workers, and Hillary is good for high-class people. And for the second one that we do, it's about some analysis of people's positive and negative attitude rate for Trump versus unskilled worker rate of each Australia's major city. So according to this above chart, we use LGA labor force dataset from Orin, which is different from last chart. It is easy to see that percent of unskilled and semi-skilled workers slow in Melbourne and Sydney, which you can see that this pink bar is very low, while there are more unskilled and semi-skilled workers in Brisbane. This part. And this also shows that Trump is advocated by those people with less income. It's actually the same as the reality that what we discussed in last part. Last one, some analysis of people's positive and negative attitude rate for Trump versus manager rate of each Australia's major city. So based on the chart above, that we use another dataset, which is the LGA labor force dataset from Warren as well. We can see that the proportion of managers, administrators, and professionals is high in Sydney and Melbourne, while the rate is low in Brisbane. It also shows that Trump got more objections by those people with high status, which is on the contrary of these two bar charts. This is actually the same as media reported also, and Trump's policy is not beneficial for the rich. And for each rate, we also have other visualization tool that could be easier for you to observe. So this one is inverted for against this bar chart, and the polar chart, which is more clear in some way. Okay. And here comes the crime case. So we generate this heat map to better show you our result. So here what we want to illustrate is to show which area people talks about more crime in main cities in Australia. As you can see, this heat map is against main cities in Australia, which includes Darwin, Perth, like the city area, Sydney, Melbourne, Brisbane, Hobart. Okay, and so after observation, we can find clear people in source part, this part, which includes some big cities, tend to talk about crime more because it's obvious that they are very colorful than other parts, such as a city area. Okay, so this means that they feel a bit unsafe about their surroundings or living space generally. On the contrast, people lived in Hobart, this area, that you can see that the heat map shows that this part is less colorful than Melbourne, obviously, and Darwin. There is basically nothing here. And there's also a bit difference between Sydney, Melbourne, and Adelaide. That we can see that if we zoom in, that we can find people talk more generally in this area. That they have more bigger graph than Adelaide. And this means that people may worry about more in this kind of cities. This actually fits the status. There are more population in these two cities, and they worry about safety issues in both the cities. And compare with Adelaide, people may think that they feel unsafe in these two cities. Okay, so I will be proudly to introduce our team members. Victor, which is our head engineer, and I can see he's a team leader. So Peter and I is in the analysis team, and we and Bing is in the website development, and is doing Harvester, and we help each other in multi directions. That's about it. Thank you for watching. Okay, so here comes the fun part. We record this just for fun. If you want to watch, you can continue, and if you are not interested, you can just skip. Thank you.
Wait. Okay.
Let's make it video. Okay, and here comes our very last part, which is our website. The website. What I can say about the website is very beautiful. So our team name is Go, and we have I have to read this for you, and I put this here because it describes what we go through. So if you cite your goals ridiculous,